So, hello everyone. Till now, we have derived all the soil water relationship formulas. So, today we'll be discussing this is actually a short video. In this video, we'll be knowing how exactly we can use this soil water relationships in practical. So actually this was one of the question that was asked by me by one professor during my PhD interview in some IIT, not in NIT, some IIT. So he just asked me, Venkatesh, I sent to a field and I asked you to find out the void ratio from that field. So how will you measure the void ratio? Generally, if you think, can we able to measure the void ratio in the field directly? Because there is no test that we can directly obtain the void ratio. So here these soil water relationships will play an important role. So can you able to guess which term will be finding out from the field to get this void ratio? So if you can able to guess, just mention in the comments that which is the term that will be actually getting from the field, so that we can find out this void ratio. So actually there is no direct method, means there not direct method in the sense there is no instrument which we can find out the void ratio from the field actually. So now I'll actually discuss how we can actually measure. For example, this is the field. Okay, this is the field. I want the void ratio E for this field. I want the void ratio E for this field, means for this soil. Okay, so how actually I can measure? I'll go to this field and I'll be measuring, and I will be measuring gamma D. Why gamma D only? Gamma D means dry unit weight. Why gamma D? Because gamma D is constant which we will be using to measure the degree of denseness of a soil, whether it is loosely compacted or densely compacted, means in which way it is compacted, what is the degree of denseness of the soil, that will be denoting or measuring by using this term only. That is why in the field and all, to know about the degree of denseness, we'll be finding gamma D only. So we will be measuring this gamma D. So how we can actually measure this gamma D? So to find out this dry unit weight, we have some methods. If it is a cohesive soil, then we will be using core cutter method. If it is a cohesion less soil, then we will be using sand replacement method, and rubber balloon method is there, water displacement method is there, but generally we will be using core cutter method and sand replacement method. So first I should know which type of soil it is at present here. So if it is a cohesive soil, then I'll be finding out this density by using core cutter method. If it is a cohesion less soil, I'll be finding out the dry density of the soil by using sand replacement method. Anyway, from the field actually we will be getting gamma B only, bulk unit weight only. So we will be finding out the water content. And gamma D can be found out. So I'll write down the steps. Actually, theoretically I explained, write down the steps. So our main aim is to find out the void ratio from the field. For that, what I have to do, I'll go to that field and I will be measuring the bulk unit weight. So for measuring the bulk unit weight, what I will be using? core cutter or sand replacement method. Core cutter method or sand replacement method. This is for cohesive soils. This is for cohesionless soils. So, and also along with this gamma B, I'll be measuring the water content as well. So after finding out this gamma B, so till now what we have known? We have known this bulk unit weight and water content also. So we have correlations like gamma D can be found out by using the formula gamma B by 1 plus W. From this, gamma D can be calculated. So one more relationship we have. What is that relationship? Gamma D is equal to G gamma W by 1 plus C. From this E can be calculated. So E is equal to, so how we can write GS gamma W by gamma D minus 1. So we have measured the void ratio in the field by using this gamma D concept. So this is one of the question that might be asked in your interviews as well. So you should be very quick. Like if they ask you how can you measure the void ratio in the field, sir, we can find the bulk density from the field and water content from the field, and we'll be knowing this gamma D for that particular soil. Then we have correlations, so from that void ratio can be calculated. So in this way you should answer. So since void ratio cannot be calculated from the field, but change in void ratio can be calculated from the consolidation. So that is again a different concept that we'll be discussing in the consolidation chapter. So till now in this video what I would like to convey to you is, so the real use of this soil water relationships in knowing the required parameter from the field, which cannot be measured by using our laboratory experiments. Means E cannot be measured, but E can be calculated from the known parameter, that is from dry unit weight. So that is what my intention. I hope this video is helpful for you. If you find this content is useful, please like my video and subscribe as well. Thank you.